Okay, I did some example problems from chapter 10.5, and these are some that you can't do as extra credit. But in number 4, we're going to test the hypothesis, and this is the format that you should be doing. You should always write your alternative. Sigma equals 35, and we're testing whether sigma has increased, which is greater than 35. We have a sample size of 15, and they tell us the population is normal. So they also told us in Part A that the sample standard deviation was 37.4, and we're going to find the test statistic. The degrees of freedom is 14, and I plug all my numbers into this test statistic, and I get 15.986. Now they told us at this alpha, let's find the critical numbers. So remember, it is a right-tailed test, so I look in the chi-squared distribution chart, degrees of freedom of 4, this is my alpha, and I found my critical number to be 29.14. Now they want us to draw it, so it's always a good idea to draw these. There is my chi-squared distribution. It's not necessarily symmetric. Since this is my critical chi-square, this is the critical region. This was my test statistic, so guess what? We're not going to reject the null. And it's because the test statistic is not in the critical region. Number 8, we have, again, we're going to write down this information, and you should be getting into the habit of writing it down as well. Sorry about that. The null is that the sigma is 1.2, and we're going to check to see if it's not 1.2. There's our sample size, and they did tell us it was normal. Now, using the information they gave us, the sample standard deviation, we're going to find the test statistic. Degrees of freedom, and it is a two-tailed test because it's a not equal. So again, this is my test statistic. I plug everything in, and I get this value. Since it is two-tailed, I need to find the left and I need to find the right. And I look in the chart. Now don't forget, I'm going to actually take my chart and I'm going to look at the degrees of freedom is 21. Okay, and then I have to look at 0.95, which is here, and then 0.05, which is this one. And those are my chi-squared critical values. And now what I have here are these are the values. And then I draw it. That means my test statistic has to be in one of these critical regions. 9.3 happens to be in this critical region, so our conclusion is that we're going to reject the null because the test statistic is in the critical region. Now, number 10, it's normal distribution. They told us what the population standard deviation is, the mean, the sample size. They also told us what the sample standard deviation was and the alpha. Now, what we're going to do is write it. We want the null to be where it stayed at 0.42, and they're wanting to know if it decreased. So I have to find my test statistics. Same process, plug in all my values, and I get this as my test statistic. Now there's two ways to do this. One is the classical value, so let me go to that first. It is a left-tailed test. Alpha is 0.01. So since it's left-tailed, I'm looking at the critical being 1 minus alpha, and I have a degree of freedom of 18, and I look on my chart, and that should be my number. So to verify it, I have 18, and I'm looking at 1 minus 0.01, which is 0.99, and there is my critical value, 7.015, which is what I found from the chart. Now, here is my test statistic. Here is my critical value. Is that in this region? It is not, so I do not reject the null. I could also look at it from a p-value. P-value is the area under the chi-square distribution with a degree of freedom of 18. So 14.75, let's look at the chart. Here is 18. 14.75 is between these two. So it's to the left, to the right of this number, which goes up to 0.90. Now remember, this is area to the right. That means the area to the left is 0.10. Now that means area is my probability. So there's my p-value, here's my alpha. It's not less than, so I don't reject the null. I need to write a conclusion. There is not sufficient evidence, or you could say there is insufficient evidence to conclude there is less variability in the filling machine. Relate it back to the problem. All right, so now let's look at alpha equals 0.27. Now, it says it's normal. It says here's my, alpha. This is sigma. Sigma is 0.27, normal distribution, level of significance. And I have to write my null, and it says that it's different. So it's a two-tailed test. I have a sample size of 16. I find my sample standard deviation by entering the data and doing a one-variable stat. And this is what I've got. I'm not going to go through those steps because you guys know how to do that. So now I can find my test statistic. Plugging in my numbers, I get this as my test statistic. Using the classical method, degrees of freedom, I have to look at the left and I have to look at the right. Now these come from the chart. My test statistic, so let me draw this. It's always easier to see it in pictures. There's the left, there's the right, there's the test statistic. It is not in these critical regions, so I don't reject the null. Let's look at the p-value. Now you can't use technology to do this. So I just looked at the chart, and left of 0.8547 happens to be 0.10. This is not less than 0.05, so I don't reject the null. Now here's how your conclusion should be written. There is insufficient evidence to conclude the standard deviation is different from 0.27.